Welcome to Tejano Virtual Events Happy Math Hour, weekly interactive math review for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carrizales, and Albert Isasi. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. This event will provide Tejano Pass for points. The code will be posted on the chat at the end of the session for Tejano Passport points. Thank you. So now at this time, please mute your mix for best sound experience. Otherwise, the feedback will interfere with the information we'll be sharing today. Without further information, here are our presenters for today.
Good morning, everyone, and thank you for joining us for the Math Happy Hour. Glad to see that we have some students in. For those of you who are here for Math 1324, you will find the link to that in your chat. So go ahead and click on that link if you're here for Math 1324. For the rest of you are here for the Math 1312, excuse me. We'll cover inverses and matrices and determinants of matrices. All right, so let's go ahead and get started. So first, let's find out what the definition of an inverse of a squared matrix is. Okay, so again, we've dealt with inverse before. Inverse means the opposite. And here in the book definition, you see that if you multiply the matrix with its opposite, with its inverse, and again, the notation that we've been using for inverse is the exponent or a superscript of -1. But when I multiply these two together, I get what's called the identity matrix, right? Which is this 1, 0, 0, 1, which we've covered before, yes? So let's go ahead and look at some examples. So it says, show that B, 1, -2, 1, -1, is the inverse of A, which is -1, 2, -1, 1. Okay, so both of these are a square matrix. The size of these matrices are a 2 by 2. So far, they're the same type of matrix, but let's see if A is the inverse of B. Okay, so to check is we'll go ahead and multiply matrix A and B, and if we get the identity matrix, the result should be a 1, 0, 0, 1, then yes, B is an inverse of A. And also we'll do it reversely, right? Because we have to get this. A times B has to give us the inverse, and also B times A also has to give us the inverse. But so let's see here. So just to review, matrix multiplication, the way we multiply matrices is row times column. So we would do -1 times 1 plus 2 times 1. That's in the position row 1, column 1. And then we do the row 1, column 2. So it'd be -1 times a -2 plus 2 times a -1. That is in the row 1, column 2 section. And then we go to the second row 2 with the column 1. So -1 times 1 plus a 1 times 1. Again, that's in the position 2, 1, row 2, column 1. And then let's do it one last time. Row 2, column 2. -1 times a -2 plus 1 times a -1. Again, that is the position 2, 2, row 2, column 2. So when we add our numbers together, -1 plus 2 is 1, 2 minus 2 is 0, -1 plus 1 is 0, 2 minus 1 is 1. So far, so good, and I believe it's going to be the inverse, but just to double check, let's do the product of B times A. And when we do B times A, we realize, or we see that we also get the identity, which is 1, 0, 0, 1. So the answer would be yes. B is the inverse of A. Okay. All right. So methods for finding inverses of a 2 by 2 square matrix. Now I do have to do a disclaimer. There is a formula that's given in your book to find the inverse of a squared matrix. Okay, so and not only any square matrix, a 2 by 2 square matrix, and the formula is given by this. Um, if we say that matrix A is A, B, C, D, then we get those variables and we do the divide 1 by A times D minus B times C times the matrix. We swap the A with a D, and then we change the sign of the B and the C, which will give us D minus B minus C times A. Now, this is a way to find the inverse of a square matrix, but the disclaimer is that this formula only works for 2 by 2 square matrix. It doesn't work for any other size of a square matrix, and it um, doesn't work for any matrices that are not squared matrix. Okay, so this is only for 2 by 2 square matrices, okay, to find its inverse. So let's practice using that formula for this problem. Find the inverse of A. So here, to find the inverse of A, here we have our matrix A, and the positions for these would be the A, B, C, D. And we know that if we multiply the matrix A with its inverse, we're going to get a the identity matrix. Yes? All right, so um, oh, so what we want to do is, this is just a formula representation of what we would do. It's another method of finding the inverse, excuse me, um, to find the inverse. Now, this method that we're showing you now can be used for any size matrix, okay, not just a square matrix. Okay, so what you want to do is you want to have this setup where you are going to want the matrix A to have the same information as my identity matrix. Yes, so let's see here. Again, I'm using the substitution. Eva, would you want to jump in for me to show this method?
Yes, sure. Thank you, Ruben. So what we're looking at here is one method. This is not the most popular method. However, if you are confident with solving systems of equations, then this might be the method for you. So basically what's going on here is, if we multiply these two matrices together, then we get, for example, 1 times x11 is x11, 4 times x21 is 4x21. And if we keep doing this row times this column now, we would get this information. And then the second row with the first one. So what happens is, if we look at the first two entries here, then we can set up a system. So you would have x11 plus 4x21. And this position is equal to 1. And then this bottom one, negative x11 minus 3x21, is equal to 0. So that's why I have the 1 and the 0 here. Well, now this little part here becomes just a system of equations. Don't let the subscripts, the x11 or the x21, scare you. It would be like if it was x and y. So here I can now do the elimination method, and I can cancel these x11s, because one is positive and one is negative. So if I add 4x to 1 minus 3x to 1, we get x to 1 equals 1. And then on the other two, I can do the same. I can set up a system here, and notice the signs are already opposite. So if I cancel those out, or actually let me go back really quick. So once that I found the x11, the x21, I can back substitute. I can plug it into one of the two equations, and that's going to help me find the x11, which is negative 3. Now we look at the second system. I can cancel the what is that, 1, 2. I can cancel that. And then 4x21 minus 3x21 is going to be a 1. So if I back substitute, then I would be able to find the x12, which is going to be 0. And so what happens is, or negative 4 if I plug it back in, right? So what happens is, we can get our solution. So x21 was 1, x11 was negative 3, x22 was 1, and x12 was negative 4. If I plot that in to an equation, to a matrix, then this would be our inverse. So again, this system is very different, but what it does is it makes them into linear systems. And if you are comfortable with the chapter 7 methods, then that's all that it is. So now if we go to the next one, the second method, this one is good because you would need to use it if you have something bigger than a 2x2, like Mr. Carizales said. So the idea of this method is you have your matrix A, you attach to it the identity, and then you use row operations so that you end up with the identity, and then whatever's left on the right side, that's going to be your inverse. Okay, so for example here, I already have a 1, which is what I want. Remember, your identity matrix is 1, 0, 0, 1. Now I can make this bottom number where I'm pointing a 0. And I can do that if I add row 1 plus row 2 and put my answer back in row 2. And so that would look like 1 plus negative 1 is 0. 4 plus negative 3 is 1. 1 plus 0 is 1. And 0 plus 1 is 1. The first row, we didn't change it, so we just copy it as it is. Now the next step is to make this a 1. And we can see that it's already a 1, so that's a good thing. So now we want to make the top number a 0. In order to make it a 0, I'm going to multiply this whole second row by a negative 4, and then I'm going to add it to row 1. Okay, so this is what that's going to look like. Negative 4 times 0 is 0 plus 1 is 1. Okay, and so we get the 1 here. And then negative 4 times 1 is negative 4 plus 4 will give me 0. And then negative 4 times 1 is negative 4 plus 1, negative 3. And negative 4 times 1 is negative 4 plus 0 is going to be negative 4. And so now you can see that on the left side, we have the identity. So that means that whatever's on the right side, that's going to be your inverse. And so we would just write it as A inverse is equal to negative 3, negative 4, 1, and 1. So here, this is your second method. This method is good if you have something bigger than 2x2. If you have a 2x2, then the third method is probably the one that most people want to use because it's a little bit simpler because they give you a formula. So here, for any matrix, you have A, B, C, D. The inverse, we're going to do 1 divided by A times D minus B times C. And then in the matrix, notice that they switched the A and the D. So now we have D and A. And then you're going to switch the signs for B and C. So if they're positive, then we make them negative. Okay, so let's practice finding the inverse. And later on in this presentation, this bottom part is actually the determinant, which we'll go into more detail later. But if you get 0 in the determinant, that means that there's no inverse. Okay, so here we have our matrix, and you could label them if it's helpful. So I'm going to have the formula. Let's apply it now. So we have 1, and then A is 1, right? D is negative 3, B is 4, and C is negative 1. I'm going to switch my A and D. So now I have negative 3 and 1. And then my sign for 4, I'm going to change it to a negative 4. And negative 1, I'm going to change it to a positive 1. So if we simplify, then we get negative 3, and then we have a minus times a negative 4 would be a positive 4. And negative 3 plus 4 is going to be 1. So 1 times a matrix is going to be itself. And so that would be our inverse as well. Okay. So these are 3 ways that you can find the inverse. If it's a 2x2, then in my opinion, the formula would be the fastest, maybe the easiest one. If you have something bigger, like a 3x3, then I would go with the second method, unless you're comfortable with solving the systems the other way. And some instructors will allow you to use a calculator. And so that would also be a way to find the inverse for anything that's bigger than a 2x2. So let's see what we can do with this. Okay, so it says use any method to find the inverse. And so we're going to use the formula. So here we have, again, 3 times 2 is A and D, and then B and C is -1, -2. I'm going to switch my A and D, so instead of 3, 2, I'm going to write 2, 3. And then the signs for B and C are going to switch. So instead of negative, we're going to have +1 and +2. If we simplify, then we get 3 times 2 is 6. And then negative times a positive here. So we have negative is +2. So we end up with 6 minus 2. And we simplify some more, and we get 1/4. Now we're going to multiply 1/4 into the parentheses. So 1/4 times 2 is 2/4, and 1/4 times 1 is 1/4. And then we get 2/4 and 3/4. Simplify or reduce your fraction. So 2/4 is the same as a half. So this is going to be your inverse. Okay. And then letter B, same idea. So here we have 3 times 2 and -1 times -6. We're going to switch the 3 and the 2. So now we get 2 and 3. Switch the signs for B and C. So we get 1 and 6. Let's simplify. 3 times 2 is 6. -1 times -6 is +6. So we end up with 6 minus 6, which is 0. And if we divide by 0, then what happens to us, Mr. Carizales? We cannot divide by 0, right? So if that happens, then we say that there's no inverse. Another way to say it is that A is not invertible. So it has no inverse. Okay. So these were just some examples using the formula. For this one, I'm not going to work it out in detail, but if you wanted to find the inverse, there's no way to use the formula. So you would have to use one of the other methods. And so here, if you wanted to use this method, I'm just going to start the very first variable because I don't want to confuse people. But if you were to multiply this out, you would take this row by the column, and then this first row by the second column, the third row by the third column. Then you would use the second row with the first column, second row with the second column, and so on. So it would look something like this. So here again, let me just explain it. So 1 times x1 is x1, and then -1 times x21 is -2x1, and 0 times x31, there's nothing, right? Because it's 0. So if you did that, then you would have something that looks like this, which looks a little crazy, but it's not a problem here. We can set up systems. So the first system would be this first column, x11 minus x is equal to 1. And then you would do the next one, x11 minus x31 is equal to 0, and so on. So you would have your system. Once you have your system, then you would go ahead and use systems of equations to get your variable. So I'm just going to go through here. If you want to come back to look at this, you can click the arrow where I'm pointing, and it'll download the presentation. So let me just keep going. So here would be your answer. But if we go to the other method, the second method is the one that's a little bit more, what's the word I'm looking for? Like, that's the one that most people would use. Here you have your A and then your identity matrix. So you would use row operations. So you want to make this one more traditional. There you go. So you want to make the 1 here a 0. So you would multiply the first row with a -1 plus 1 would give you that 0. So here are the row operations. And as you can see, if we do the row operations, then we would end up with the identity matrix here, and whatever's left here is your inverse. Okay. So, but what is the point of all these inverses, right? There has to be a point why we want to find the inverse. So one of the reasons we want to find this inverse is to solve the system. So it goes back to solving a system. And in chapter 7, you learned methods. You learned substitution You learn elimination. Last week in happy hour, we talked about solving a system using Gauss-Jordan elimination. So you have all these different methods. So this is another way to find the system. And so the way that we can solve the system is you would take the inverse and multiply it times B. And we'll talk about what B is here in a second. So if you had this question, use the matrix to solve the system, then the way we would set it up is your matrix A is the coefficients of your system here. So you have x is 1, y is -3, x is 3, and then -8 is here. So the matrix A is made up of coefficients. The matrix B is made up of constants. So in this case, 4 and 12. And then x is just your variables, okay? So here in this problem, they already give us your inverse, okay? So they already have your inverse. So here we're gonna have our inverse, which is given, -8, 3, -3, and 1. Then we're gonna multiply it to b, so we have 4 and 12. So if we use multiplication, we have -8 times 4 is -32, 3 times 12 is 36, and -32 plus 36 is 4. And then the second row, -3 times 4, -12, and 1 times 12 is 12. So -12 plus 12 is 0. So that means my solution is x is 4 and y is 0. Okay, so what if they don't give you the inverse? Because here they gave you the inverse. So let's do an example. So first, we need to get the stuff that we need. So matrix A is 1, -5, 5, and -24. Again, that comes from the coefficients for our variables here. And then letter B is, or matrix B is going to be your constants, 27 and 128. And so what we want to do now is find the inverse because we need the inverse. So to find the inverse, we have 1 divided by 1 times -24 minus -5 times 5. We're going to switch the 1 and -24. And then we're going to switch the sign of -5, so that's +5, and switch the sign of +5 to -5. Simplify. We get -24 minus a -25. And that becomes a +25. So -24 plus 25 is 1 divided by 1. So this is our inverse. Now that you have the inverse, we set up the equation. So x is equal to a inverse times b. So this is our inverse, and then b is 27 and 128. So we're going to multiply -24 times 27 and 5 times 128. So here it's set up, and then -5 times 27 and 1 times 128. So if we use the calculator, we end up with -648 and 640, -135 and 128. So -648 plus 640 is -8, and -135 plus 28 is -7. So our solutions are x equals -8 and y equals -7. And so some instructors, like myself, we do like our answer to be put in as a solution set. So let me just write it here. And that should have been curly brace, but I apologize for that. So that would be my answer. Okay, so now for this one, you have a system. And so we have, the good thing is they give us the inverse, so we don't have to find it. So here's my A. It's going to be all the coefficients. So we have 111, 354, and 365. B is 063. Since they give me the inverse, I'm going to just write my inverse here, times 063. So we would have 1 times 0 is 0. 1 times 6 is 6. Negative 1 times 3 is 3. So if I add all that together, I get a 3. And then the next one, negative 3 times 0 is 0. 2 times 6 is 12. And negative 1 times 3 is 3. So 12 minus 3, 9. And then 3 times 0 is 0. Negative 3 times 6, negative 18, plus a 6. So we get negative 12. Okay, so that is how you would use the inverse to solve a system. And then the last section is on determinants. And so the determinant, if you have a matrix, here we have A equals A1, A2, B1, B2. If you find the determinant, there's different ways to writing it. So one way is you have DET, that means determinant of A. Another way to represent that you're looking for a determinant is these vertical lines, right? And then when you're actually going to find it, we use vertical lines instead of the brackets here. So the determinant is just found by multiplying A1 times B2 and B1 times A2 and subtracting. Okay, so it's A1 times B2 minus A2 times B1. So let's find the determinant of these. So for A, I'm going to find the determinant of A. So instead of my brackets, I just change them to vertical lines. And we're going to multiply 2 times 2 and negative 3 times 1. So 2 times 2 is 4. And negative 1 times negative 3 is positive 3. 4 plus 3 is 7. Letter B, same idea. So 2 times 2 is 4. 1 times 4 is 4. So 4 minus 4 is 0. So the determinant here is 0. That means there's no inverse for that matrix. Okay. And then letter C, 0 times 4 and negative 2 or minus 2 times 3 halves. So we get 0 minus 3 is negative 3. So that wasn't too bad, right? 2 by 2s are pretty easy to work with. But what about something bigger? So for something bigger, like 3 by 3, 4 by 4s, or n by n's, we're going to need something called a cofactor. So we need to have this pattern. We'll come back to this pattern here in a little bit. Okay? So let's go back to finding the determinant of this. Again, we are going to use this, but we'll come back to it here in a second. So if you want to find the determinant of this, then what we want to do is kind of break it down so that we have smaller matrices like 2 by 2s. So one of the things you can do is kind of cross out the first row and the first column. And if you notice right in the middle, you're left with a 2 by 2. And so we can, those are called minors. So we would have the first position and the first row. So we're using number here. And we would find the determinant of what's left over. So negative 1 times 1 and 2 times 0. So negative 1 times 1 is negative 1 minus 0 is negative 1. And then we keep going. So now I'm going to use this second number and I'm going to cross out the row and I'm going to cross out the column where that number is located. And if you notice, we have 3, 4, and 2, 1. So that becomes our smaller 2 by 2 that we can use. So 3 times 1 and 2 times 4. 3 times 1 is 3 minus 8 gives us negative 5. And now we're going to cross out where the 1 is. So I'm going to cross out that row and that column. So now I'm left with 3, negative 1, 4, and 0. So 3 times 0 is 0. Negative 1 times 4 is negative 4. So we end up with 4. But that's not the end of it, right? We still have to consider, now let's go down the first column. So 3, I cross out the row, second column, the first row, second row. Sorry, the first column, second row. So we're left with 2, 1, 0, 1. So 2 times 1 is 2. Minus 0 is going to be 2. And now I'm going to use the next one, negative 1. So I cross out this row and this column, we're left with 0 and 1, and 4 and 1. And so 0 times 1 is 0, 4 times 1 is 4, 0 minus 4 is negative 4. And so we keep going down the same way, and then we go down to the last row and we do the same thing. And so we're going to end up with all these minors here, six of them. So right now I did 5. You would do the one with the 2, then you would do the one with the 4, the 0, and the 1. Okay. So once you get your minors, which are right here, then we're going to take those minors and we're going to look for the patterns. Okay, so our matrix is a 3 by 3, so this would be our pattern. So you're going to take the minor, and if you notice here, you have the minor is -1, and then we have a positive. So -1 times a positive is going to be negative. So we still keep -1. And then we check the next one. -5 times a negative would make it a +5. And then we go to the next one. 4 times a positive is going to be +4. And then we keep going. 2 times a negative would make it a -2. And if we keep doing the same for each one, then we end up with this. Okay? So what we're going to do now is the determinant is going to be the sum of any row or column once we have multiplied by the cofactor. And so here we can take, so we did the 0 times 1, and then the 2 times 5, the 1 times 4. And so we would end up with 0 plus 10 plus 4, and then we would get our 14. But if you take any row or any column, then we would have that same number. So here you have 0 times -1. That's your 0 times -1. You have your 2 times the 5. That's where we get 2 times 5. 1 times 4 is 1 times 4. So you get 14. But you can pick any of them. So we would have 3 times -2, -1 times -4, 2 times 8, and you still get 14. So you can choose any of the rows, okay? And so your determinant is going to be 14. So what is the point of the determinant? So it always goes back to the point. So the point is to solve the system, right? That's the whole idea of chapter 7 and chapter 8 is solve the system. So we're just giving you tools, and then you can pick whichever tool, unless your instructor says solve the system using Cramer's rule. So this is Cramer's rule. So for Cramer's rule, you have to have a coefficient matrix, which is made up of all the coefficients. So in this case, A1, B1, A2, and B2. Then we're going to find the determinant of those coefficients. And then we're going to need a dx, okay? Dx is going to be the constants, which are C1 and C2, and the coefficients of B1 of the y's, so the coefficient of y's. And then dy is going to be the coefficients of x, so A1, A2, and the constants. Okay, once you find the determinants, then to find x, we're just going to take dx divided by d, and y is going to be dy divided by d. So let's put it all together and do an example. So here, let's get the things we need. So we need the coefficient matrix, we need d, we need dx, and dy, and the constants. So let's set it up. Our coefficient matrix would be 4, -2, 3, and 5. Okay. So if we find the determinant of that matrix, we get 4 times -5 and -2 times 3. So we get 20 plus 6 will give us -20 plus 6, -14. Now we need to find dx. So remember, dx is the constants. So our constants are 10 and 11, and the coefficients of y, which are -2, -5. So 10 times -5 and -2 times 11, we end up with -28. And then the last one that we need is dy. So that's your coefficients of x and your constants. So we're going to have 4, 3, and 10, 11. 4 times 11 is 44. minus 30 will give us 14. And so now we're ready to solve the system. So for x, we get dx, which was 28, negative 28, and then d was negative 14. This one's d, and this is x. So we end up with a 2. So my negative, I put it here, but it belongs with a 28. So we get a 2. And then y is going to be dy is 14, and d is negative 14. So if we divide, we get negative 1. So that would be our answer there. Okay. So that is how we would solve the system using Cramer's rule. So we still have a little bit of time, so I'm gonna show you, let me just find it on my computer first, how you can use your calculator if you're allowed to use a calculator. Again, this only depends on your instructor if they let you use a calculator or not. So let me find it on my computer really quick. See if I can find it here. In the meantime, if you have any questions, you can ask us. Let me just find the calculator and then, okay. All right, so let me share my screen. Okay, so can you guys see my calculator? Yes, okay, cool. All right, so if you have a calculator, this is an old calculator, it's an 83, but if you have an 84, it still works the same way. The smaller calculators, like a Casio, can do some matrices in there, but I don't have a screen to show you for that one. So if you do have a graphing one of the things, the first thing you would have to do is you want to enter your matrix. So here you have second matrix. So you would press second matrix. Then you're going to edit the matrix because you want to put in your own numbers. You have to put in the size. So let me just put 2 by 2. So you enter the 2 and then you press enter. So you're going to put in some numbers. I'm just going to make up whatever. So 4, 5, 6, and 2. Okay. So now my matrix is in there. I'm going to second quit. And then if you want to find the inverse, you press second matrix. And we want to work with A. So I'm going to press enter. So now you see your A is there. The inverse sign is this one here, x to the negative 1. So I enter that. And then it gives me my inverse. So right now it looks pretty ugly because you have a whole bunch of decimals, right? If you want to make it more visible or you want it into a fraction, you press math and the number 1, enter. And then you have your inverse. So that would be your inverse. So if you had a 3 by 3, and if you're allowed to use a computer, or not a computer, but a calculator, I guess it's a computer, then you can just use that in here, put it in here. Okay, let's see if this has an inverse, since I just made them up. Okay, so let's go second matrix. I put in my information, inverse. And again, if you want to have it in fractions, then you would see your inverse here. Notice that you can't really see this, but you can just scroll and it'll let you see the rest of the matrix. Now, what about the determinant? The determinant, you would click on math, and it's going to be that first one. So you press enter, and then you go get the matrix, press enter, and enter. And then it would give you your answer, negative 22. Since we're in this, I guess I can also show you how to use, if you wanted to solve the system. So if you wanted to solve a system, let's say you had like 2x plus y equals 8 and 3x minus 4y equals 10. So you have a system, you can press second matrix. I'm going to edit this, and this is going to be a 2 by 3. And so I said 2x, so I would put my 2 for the x, a 1 for the y, and then the constant was 8. And then the second equation was 3x, so I put a 3 plus minus 4y, so minus 4. And then the constant was 10. So my equation is, my system is in there. So if you want to use matrices, remember what Mr. Carizales covered last week, the reduced row echelon form, which is the Gauss-Jordan. And if you press enter, I'm going to put A. Then it would tell you your answer. You notice your identity is here, 1, 0. Let me make that into a fraction. So your answers would be 4211 and 411. So that's if you're allowed to use a calculator. If you don't have a calculator, but they let you use the app for decimals, then this one will also, or if you just want to check your work, you can go to Math Tools, Matrix Calculator, click on New Matrix, and let me just put in some numbers here. And 7, it's fine. All right, so I'm going to press enter. So let's say you want to find the inverse, you would press A inverse. Oops, let me clear that. Okay, let me press enter. So you would press A because that's the name of your matrix, then the inverse, and you would press enter, and it would give you your answer here. If you want a fraction, then you can just click the symbol to get a fraction. If you want determinant, you would click determinant, A, and then enter. And that's 37. If you want to solve the system, you would press RREF, and that would give you the solve system if you're working with the system. So anyways, so in some of our classes, we don't let you use a calculator or a computer, but you can always use that to check your work if you're doing homework. That way you can just double check your work. But anyways, if you don't have any questions, that was it for the presentation. You can stay here and ask us. Hopefully everybody downloaded the PDF file. But I'm gonna pass it over to next week. We're gonna review for your final, so hopefully you can join us for that too. So I'll pass it over.
Thank you, Ms. Chuka, and thank you, Mr. Carrizales, for your wonderful presentation. We do want to remind you all about your previously recorded sessions, which are available on YouTube playlist. Today's session will also be available on that playlist later on today. Also linked is a short survey to help us improve our TVE sessions, so please take the time to fill out the survey. Before you all leave, I want to share the TVE sessions that we will have next week. We will be back with a Happy Math Hour next week at 11, where Math 1314 and both Math 1324 will be covering your final exam reviews. Next week also, Student Success will be covering Children's Program at Northwest Campus and the Children's College. Today at 1 p.m., we will also like to invite you. We will be having the Student Success presenting EPCC Mental Health Committee. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, like Ms. Chuka said, feel free to use the chat or open up your mic. If there's no questions, I hope to see everyone again for Happy Math Hour next week. Have a great weekend.